Good morning, students. So, as discussed in the previous class, in this class we will be talking about the mechanism of monsoon. So, till now we have studying the basic with factors which are important for the development of or the change of the climate. But this thing in this topic we will specifically be talking about the mechanism of monsoon, or you can say the factors which are responsible for this intense monsoon in India. Although monsoon is a common rainfall method or phenomena which is active, which took place in various other part of the world as well, including California or some part of Australia. But the intensity of monsoon in India is so high, and it is so innovative, it's so different in India that the whole phenomenon in India has been named after the country, that is the Indian monsoon. So, starting from the first mechanism, which is the most common mechanism, is the differential heating of land and water. Why in India we receive monsoon rainfall only between June to September? Because of the prevailing conditions. During June to September, before June, we have the month of April and May. And April and May is the season of summer in India. And we all know that during summer, we receive sun in the month of June or after January. Sun starts moving towards Tropic of Cancer to Tropic of Capricorn, Tropic of Capricorn to Tropic of Cancer. So when on 21st June, sun shines over Tropic of Cancer, before that, April and May, it is shining vertically over this whole tropical region. And due to this direct absorption of insolation from the sun, the land over India, the land part of the country, get intensely heated. And due to this high insolation, this northern part of the country, including this Tibetan plateau, because if you see that these regions are quite far from the sea, so the moderating effect of sea is not found over these places. Because of this, during summer, this land area get intensely heated, and a low pressure area developed over this part. A very intense low pressure area, because land is intensely heated, and due to that hot land or heated land, the air above that piece of land get warmed up and it rises up in the air. And due to this hot air, because the air is constantly rising, a low pressure area develop over this part. Okay, and this low pressure area attracts the wind from these water bodies, because the time when in this land is getting intensely heated, the water is still taking time for getting heated. So because of that, here we have low pressure, but here we have extremely high pressure developed. All right, so this is why this differential heating causes the change in the direction of wind and the attraction of the wind from the high pressure area. So that is why it is so simple, because this monsoon phenomenon is simple. The concept of land breeze and sea breeze, which you have studied in your junior classes, that during daytime when land is extremely hot and it receives insolation, the water is comparatively cold, and high pressure develops over sea and low pressure develops over land. And because of that, during daytime, the wind moves from ocean to sea to land. That is called sea breeze. And similarly, during night in the coastal areas, because the water now is warm and land in the lack of insulation is cold, so high pressure develops over land and low pressure develops over water. So during night in the coastal areas, the wind will move from land to sea. So every day in the coastal areas, they receive wind, this blowing of the wind. They experience this fast blowing wind. During daytime, it is cool because it is coming from the sea, and it is nighttime also it is cool because it is coming from cold land. So that is why coastal areas have this moderating effect, because throughout the day they receive land breeze and sea breeze. So this monsoon, you can term this as a large scale land breeze and sea breeze, because during summers the wind is coming from sea to land, and during winters the wind will move from land to sea. All right, so this is the differential heating of land and water causes the attraction of wind, moisture laden winds towards this low pressure area which develops over the northern part of the country. Okay, so what NCERT is saying, that differences in heating and cooling of land and sea. The land gets heated rapidly and sea takes time in absorbing and releasing heat. And it creates low pressure area on land and high pressure area over the sea. Now the second mechanism, which is very important mechanism, is the shift of ITCZ zone over the Ganga. Now, can anybody tell me what is this, the concept of ITCZ? Anybody? Intertropical Convergence Zone. Any idea which you remember? Anything which you remember about Intertropical Convergence Zone?
Can I?
Mm-hmm.
When the sun's heat directly falls on the equator and zone is created, that is known as the intertropical convergence zone. And when the sun rays fall directly on the Tropic of Cancer, they move above the equator, and when it falls on the Tropic of Cancer, it moves down to the equator. Basically, all the high pressure winds move to this area.
All right. Okay, much, very much close. Madhu, can you throw some light on the concept of Intertropical Convergence Zone?
Ma'am, the southern hemisphere winds and the northern hemisphere winds meet at the equator. That place is known as tropical ITCZ.
Very good. Okay, both of you are partially correct. So, why these winds? So, in when we were discussing this intertropical convergence zone, the basic principle behind ITC is that the basic principle behind this movement of wind will always be low pressure and high pressure. So, you, as you can see, this is the wind diagram of the Earth's surface. This is equator, 0 degree latitude, and because this is the straight line, this is Tropic of Cancer and this is Tropic of Capricorn, and this is the zone which receives vertical rays of the sun, and this vertical rays of the sun is produce intense heat in this zone, and due to that it's a low pressure area, a low pressure zone develops over equator. All right, and because the rest of the world, being it northern hemisphere or the southern hemisphere, because they are comparatively high pressure area. Okay, in comparison to the equatorial low pressure area, the wind moves from this high pressure to this low pressure throughout the year. That is why they are also known as the temporary permanent winds or the trade winds. All right. So this high pressure winds. Sorry, children. So this high pressure area, these high pressure winds constantly move towards this low pressure area. All, but where the area, because they are coming towards this, and these low from winds from the northern hemisphere are moving towards this direction. The direction is your northeast. The direction is this pink arrow which you can see is the northeast winds, and this arrow which is coming from the southern hemisphere, they are southeast winds. You see the name is also written. The
Yes, ma'am.
wind which is coming from northern hemisphere, they will be northeast because they are coming from the northeast direction, and the wind which is shown here, that is southeast winds because they are coming from southeast direction. Now, what is the role of this ITCZ in the Indian monsoon? Like, our main question is that ITCZ, Madhu has already explained, Anshu has already explained that area where these
Ma'am,
two
there
trade
is
winds
written
meet.
north. जी मैम मैम जहाँ पे नॉर्थ ईस्ट ट्रेड विंड लिखा है वहां से विंड्स आते हैं.
नॉर्थ ईस्ट ट्रेंड विंड जहां पर लिखा है मधु, उसका ये मतलब है कि दिस विंड्स आर कमिंग टुवर्ड्स दिस लो प्रेशर एरिया फ्रॉम दिस रीजन. ठीक है, तो ये रीजन कौन सा है? ये हमारा ट्रॉपिकल रीजन है एंड सम पार्ट ऑफ टेम्परेट रीजन. मधु प्लीज स्विच ऑफ योर माइक बेटा प्लीज. Okay, so that is why they are coming, and rest of the temp this area receives different kind of wind that is out of syllabus, but we right now we are talking about the trade winds, and the zone of trade wind is between Tropic of Cancer and between Tropic of Capricorn. Okay, so from the subtropical area, they high pressure, they are coming towards this equatorial low pressure area, and because they are coming towards each other, obviously they will converge somewhere. So most of the time what we think that they converge at the equator. Yes, they converge at the equator, but only when the equator is the sun is shining over the equator, not throughout the year, because the movement of sun takes place, changes its position constantly. Throughout the year, sun moves from north to south, or Tropic of Cancer to Tropic of Capricorn, and Tropic of Capricorn to Tropic of Cancer. So when sun is shining or sun is overhead on equator, the ITCZ is situated on the equator. then wind will come and converge at this place, its zone. But when the sun is shining over Tropic of Cancer, the position of ITCZ will shift north of the equator. At this, similarly, when the sun is shining over Tropic of Capricorn, the ITCZ will shift south of the equator. All right. So our consideration is why ITCZ is important for the development of monsoon. So when ITCZ, when sun shines over Tropic of Cancer, that is on 21st of June, the ITCZ shift north of the equator. And when ITCZ shifts north of the equator, for convergence, the southeast trade winds has to cross the equator because it has to converge and it has to reach ITCZ. It has to converge with northeast trade winds. So as soon as the southeast trade winds crosses the equator, due to this centrifugal force of the earth, which is highest at the equator, the direction of the wind, the southeast trade winds deflect towards their right. And because of because they convert, they deflect towards right, their direction changes from southeast to southwest, and they enter into Indian mainland in the form of southwest monsoon. So if this whole process of deflection after crossing the equator, the wind deflect towards their right, and after crossing the equator, the northern hemisphere wind deflect towards their left. That this concept is known as Coriolis force, which we have discussed in the yesterday's class. Remember?
Yes, ma'am.
So this
Yes, ma'am.
southeast trade winds, these monsoon winds are not an innovative wind which develops some randomly. It is only our southeast trade winds which deflect towards right after crossing the equator, and they convert into southwest monsoon. They enter into India, and because they bring lots of moisture into Indian subcontinent, they bring rainfall between June to September. Okay. So now you got the
Okay.
concept of ITCZ.
Yes, ma'am.
Yes, ma'am.
Now, the third mechanism of monsoon, children, is the presence of cold pressure or high pressure area east of Madagascar, approximately 20 degrees south over the Indian Ocean. The intensity and position of this high pressure area affects the Indian monsoon. This is Madagascar. This is an island in the Indian Ocean, island country in the Indian Ocean, and somehow during summers, a high pressure area develops at 20 degree east or south of this island. And you can see Indian Ocean is the water body which surrounds India also. So if some part of Indian Ocean is getting high pressure, getting colder and colder, the influence, because water will mix everywhere. It's not a confined boundary. So this cold area, cold water will decrease the temperature of the whole Indian Ocean, and it will intensify the pressure gradient. It will make high pressure of the Indian Ocean more high, and obviously in during summers the low pressure area in the north of India and Tibet is already low. So this will create a very steep pressure gradient, and wind will start moving towards Indian low pressure with a very big high speed. And all this moisture which you can see here from Indian Ocean, from Arabian Sea, from Bay of Bengal will come to India in the form of rainfall between month of June to September. In this mechanism, you only have to remember one thing, that this part of Madagascar island becomes colder during summer season, and this causes intensify the high pressure area in the Indian Ocean, which ultimately leads to the movement of wind towards the low pressure area of country. Then at one place, that is Madagascar, it is getting colder and colder. At another end, that is the land part, Tibet, it is getting hotter and hotter. So when low pressure is getting extremely low and high pressure is getting extremely high, obviously the pressure gradient will steep, or pressure gradient jitna steep hoga, wind movement will be that high. इतनी तेजी से हवा आएगी, और जितनी तेजी से हवा आएगी उतना ज्यादा मॉइस्चर हमारे देश में आएगा और उतनी अच्छी रेनफॉल होगी. तो तिब्बत इज अ प्लेट्यू. Plateau is a storehouse of minerals, and it absorbs lots of heat. And because of this heat absorption, it becomes extremely heated during summers, and extreme low pressure area develops over the sun, in the summer month. And this extreme low pressure area attracts the wind from south, all the water bodies surrounding the peninsular part of India. All right. So the next mechanism, this is our fourth mechanism. The Tibetan plateau gets intensely heated during the summer, and this results in a strong vertical air current and the formation of low pressure over the plateau above 9 kilometers sea level. Okay, and this is the last but not the least, which leads to the concept of development of El Nino or La Nina in our country. So Tahiti is a point in the Pacific Ocean. You can see this is the Pacific Ocean. This is North America, South America, Australia, and a part of Asia. This is our Pacific Ocean. All right. Identify kar pa rahe ho na? This is Pacific Ocean.
Yes.
So Tahiti is a point over Pacific Ocean, and Darwin is a point over Northern Australia. And both these points are used to calculate the temperature differences. And it was also used for predicting the intensity of the monsoon. So inka pressure gradient jitna hai, because you can see here pink color is showing the warm water, that is low pressure, and this blue color is showing the cold water, and that means high pressure. So in normal condition, when monsoon is good, this part has to be cold, or you can say high pressure should be developed over here, and this low pressure should be developed over here. All right, because during summers, if ocean is not high pressure, is not cold, then obviously there will be no pressure gradient and wind will not come to India or come to low pressure. So these 2 points are used to check the gradient. So gradient jitna zyada hoga, matlab low pressure jitna low और high pressure jitna high होगा between Darwin and the Tahiti, उतनी strong, इतनी अच्छी monsoon हमारे देश में आएगी. But if the pressure gradient is less, मतलब Tahiti का temperature और Darwin के temperature में कम difference है, that means signifies the failure or delay in the monsoon in Indian mainland. ठीक है, आप देखो नीचे लिखा भी हुआ है, if the pressure differences are negative, it would mean below average on the late monsoon. Negative का क्या मतलब है कि suppose तहीती के ऊपर 30 डिग्री सेल्सियस का टेम्परेचर है और डार्विन के ऊपर you can say 40 डिग्री का टेम्परेचर है, तो 30 minus 40 minus 10, मतलब कि जहां ठंडा होना चाहिए पानी गर्म है, और जहां गर्म होना चाहिए लैंड वो ठंडी है. ठीक है, या फिर इन शॉर्ट आप समझ लो, पानी जब ठंडा होना चाहिए वो पानी गर्म है. तो वाटर इज आल्सो वार्म, लैंड इज आल्सो वार्म, दैट मींस देयर विल बी नो प्रेशर ग्रेडियंट एंड no wind movement will take place. And if there is no wind movement, the monsoon will fail. All right, the one more phenomena which is associated with this is the concept of El Nino, which affects Indian monsoon to a great extent. This is also one of the major economic threat nowadays, but this we will discuss in our next class. In today's class we will wrap up at the mechanism only. तो आज की क्लास में बच्चों हमने क्या पढ़ा, that 5 mechanism of the monsoon which are responsible for intense monsoon over the Indian mainland. And these 5 mechanism of monsoons are: number 1, the differential heating of land and water. The second one, the shift of ITCZ. The third, the development of a high pressure area over 20 degrees south of Madagascar. Number 4, the intensive low pressure area which develops over Tibetan Plateau during summers. And 5, the fifth mechanism, the temperature difference between Tahiti in Pacific Ocean and Darwin in Australia. So I hope these mechanisms are clear to all of you, because it is one very, very important question or descriptive question for 5 marks. And if there is any problem, you can ask. Otherwise, you can leave the meet, and we will meet tomorrow again. And thank you for joining the class.